Question 14. This is a deep beam problem. This is from chapter 2.11, and here we've got a concrete beam which is a quarter of the height is a quarter of the span. It's restrained at floor and roof levels. It's got a thickness of 200 millimeters and loading for floor, roof and self-weight of the wall, which are given. The loads are unfactored, so we're going to have to apply an ultimate factor if we're looking at the bending moments and ultimate shears. For deflections, we ignore this factor because this is a serviceability limit state. Question 14a. So we put the dimensions in. We've got the floor loading of 40, wall of 14, roof of 32 kilonewtons per meter. So we add all those together, they're all acting on the beam, so 32 plus 14 plus 40 is 86 kilonewtons a meter. Applying the ultimate load factor of 1.5 to obtain bending and shear gives you 129 kilonewtons a meter. So then we work out the maximum ultimate moment using these figures. So M is WR squared over 8, which comes to 2322 kilonewton meters ultimate. The shear comes from WL over 2, and if you take that you get 774 kilonewtons, 774 kilonewtons meters. Question 14b, and we're now going to find the reinforcement using the figure 21112 with a lever arm 0.62 times depth. So the force in the reinforcement is M over LA, which is 2322 over 0.62, and the depth of 3.3 gives you 1248 kilonewtons. So the area of steel, you divide this by the yield of steel, so you get 2496, and the area of each bar, 25mm bar, is 490, so you divide that by 490, you get 5.1, so we round this up to 6, and this is a reasonable approximation for the deep beam. We'll distribute, say, 3 near the bottom of the beam, something like 200mm apart. Question 14c, and we've got the shear reinforcement to calculate and check the maximum shear in the section. So the shear stress is 774 divided by 3 meters divided by 2 approximately, which is 1.3 newtons millimeter squared. Approximate formula for shear reinforcement, which is not in the book, is given SVWVS over Fy. So SV is the spacing, W is the width, and the shear, and you take the Fy reinforcement, you come out with 130 millimeter squared, 2 times 10 millimeter bars, which are bent as links, will give you approximately 157, which is greater than the 130 area. So we adopt 250mm centres, then this will be appropriate, remembering that this is very much a conservative shear formula. Thank you for listening. Thank you.